Hi, I'm James the Light Guy, and today we're taking a look at some AOLED LED headlights. Today's bulbs are in the bulb type 9012, and you can see the first thing in the box is a very similar product manual to many of the other LED bulbs that we've seen in the past. These bulbs are available on Amazon, and I will put a link in the description below if you'd like to get them for yourself. So we got a manual, a tiny Allen wrench or hex wrench, and a pair of LED bulbs. Let's put this in the back like that, nice and pretty. Let's take a look at one of these bulbs. So this is a 9012 bulb type. It is the same connector, base, and general form factor as a 9006. Let's zoom in a bit. Starting with the connector, it is a very similar connector as we've seen in the past. Actually this one's a bit softer than normal. 9006 bulb type connector with the positive and negative clearly identified, and limited strain relief. It's thin and flexible over here, but fairly rigid over here. I'd like to see the opposite. I'd prefer rigid here and flexible on this end. Then we come down to the control box. The control box has some limited heat sinking on it and a actually really nice silicon strain relief on both the input and output sides. In this control box we have a CAN bus decoder. This is a CAN bus rated bulb, so it should prevent any flickering in most vehicle applications, as well as not alert your vehicle to display a bulb out warning. It also controls the fan with thermal sensor, so it'll throttle back the light and crank the fan to keep the bulb from burning out, as well as some electromagnetic shielding to try and prevent static on the radio. Moving further down to where the the wire meets the bulb, there is no strain relief here, and if I change over to the other bulb, we can see it's already separated fresh out of the box, exposing the wires. That being said, it looks like we can see 4 wires, a blue, red, white, and yellow wire. I assume 2 are fan control and 2 are power to the LEDs. I don't know how it regulates the temperature unless it's basing the load or resistance from the chips as they overheat or as they heat up to control the fan. It could be a very smart bulb, but we'll have to see in our testing. Moving on to the shroud, this is just a punched metal shroud that's been anodized. We have a large fan. This fan is supposedly rated at 15,000 ripms, so that's going to be a lot of airflow. And we have an aircraft grade aluminum heat sink down here with a lot of surface area. That should do a fantastic job of getting heat away from the bulb. We have the 9006 base type, and I believe somewhere under this O-ring, or maybe it's through this little hole here, is the nut or bolt, that set screw that the Allen wrench is used to retain this plate. Moving up the shaft, we see that it is two-sided and held together with a single screw at the top, and we have 2 CSP chip sets at the end here. The boards that the chips are on have a copper substrate to help transfer that heat down away from the chips to the heatsink and evacuate it, keeping the longevity of the bulbs high. Let's grab our power supply and turn these on and see how they look. These bulbs are marketed as 80 watts a pair, 40 watts each. Let's turn on our power supply. And you see when we first turn it on, it's fairly bright looking directly at it and a bit dimmer off to the side. At 14.4 volts operating voltage, we are drawing just shy of 2.5 amps, which currently puts these bulbs at 35 watts, a bit shy of the 40 watt rating, and that amperage is slowly dropping. It'll probably stabilize soon. Also, the fan was relatively quiet when I first turned it on, but has gotten a bit louder. I'll bring it closer to the microphone. It's not loud enough to be noticeable while installed in the vehicle. And the shroud seems to do... oh, never mind. I was gonna say, it seems to be doing a good job keeping objects from getting inside, but I could fit my whole thumb in there to touch the fan blade. It's also a bit deep, not too bad. Looks like we have about, use our board here, about 1 inch from the base plate to the back of the heatsink fan shroud. So that will determine how much space you have, or the space you have in your housing will determine whether or not you'll be able to use this. Grabbing onto the heatsink right here between the base plate and the fan, I can feel quite a lot of warmth, so that copper substrate is doing a great job transferring heat away from the bulb and down toward the fan. Let's grab our light measuring box and see the difference between the darkest point and the brightest point. I'll be right back. We now have our meter set to times 10 per normal, and what we're going to do is start by placing our bulb in with the shadow facing the sensor and get our lowest brightness measurement, and then rotate the bulb 90 degrees so that the chipset is facing the sensor and figure out what our brightest is. Let's turn this on. You can see we're at 14.4 volts and just shy of 2.5 amps. Let's drop it in here. And you can see at darkest, we are just over 300 lux. And at brightest, we are just over 1300, so 1000 lux difference. Let's get this into a housing and see if the reflectors or projectors will do a good job of compensating for that dark spot. As you can see, we now have the bulb installed in a reflector type housing, and we've dropped down below 2.4 amps. Let's turn off the overhead lights and check the beam pattern. Once again, in line with this support column, puts us 4 meters away from the wall. We started our test over here on the left or oncoming traffic side, move our way to this bright spot here, and then off here on the right side or wood line, and then progress downward. This left side measured in at 50 lux. The hot spot, or rather the center of the hot spot, if we show up there, right on this dot here, was 480 lux. and this side back down to 40 lux. So a little bit brighter on the oncoming traffic side and dimmer off into the woods. Going vertically, we had our 480 followed by 130 and then down to just 30 in this spot here. Let's switch over to our projector housing and take some measurements. Here we are with the bulb mounted in our projector style housing. I used the included Allen key to set the chips at the 9 and 3 o'clock position per the manual, but as you'll see in a minute, the beam pattern is not perfect. We're still drawing just shy of 2.4 amps, and this up curve here on the left is because our backdrop is actually pulled forward from the wall a ways, and that's just because of the angle of the beam from the headlight to the wall. I have them aimed up a bit to make it easier to see. Starting over here on the left, I only got 20 lux as our measurement, significantly lower than the reflector housing. The reflector housing had this spot being a hot spot that you couldn't see at this range, if you recall. That was 480 with the reflector. We are down to 150 here in the projector housing. At this spot here, we are down to just 17 lux. The point in the middle below our center line was 75, and this measured in at 5 lux down here. As you can see, these bulbs do significantly better in a reflector housing than a projector housing, or at the very least, this particular one. Let's see if we can get a couple of outside shots on a road, and then we'll come back to the studio for our conclusion. One last note before our conclusion. Using the Allen key to loosen and remove the adapter plate, I was able to find a second retaining screw clamping this assembly shut. Tighten that back up. So, conclusions. In reflector housings, these appear to be much better than they are in projectors, but that's subject to the housing itself. Your mileage may vary. It did get fairly warm during my testing, not enough to, I would say, be concerned about, but depending on how this intelligent controller measures that heat, whether it's by resistive load or otherwise, if it can't solve the problem with fan speed, it may start to dim the chips in order to keep them from dying completely. The control box got, I'd say, warm, not hot, but above ambient temperature. So either this little bit of heat sinking does something, or it just generally didn't get hot enough to need. As I said, these bulbs are available on Amazon. They have a 5-star rating, and for their price, I would say that they are an adequate entry-level bulb. I just started a Patreon. Feel free to pop by at patreon.com/JamesTheLightGuy. If a few people throw a dollar or two in the bucket, maybe we can afford to do a big project each month. In any case, that's all I have for today's video. I hope you enjoyed it, and if you did, give me that thumbs up, like and subscribe, share with your friends, and until next time, I'm James the Light Guy.